Sorry. Yes, dear friend, in last video I told you how to calculate work done. So that dW I told PdV, and if volume changes from V1 to V2, then W is equal to integration dW V1 to V2. It is equal to integration PdV V1 to V2. And if pressure gas of gas remain constant, volume change V1 to then P into V2 minus V1. But during any expansion or compression of thermal system, pressure does not remain generally constant, keep on varying. Then how to calculate work done? Basic method is this, integration. We will be doing this, following this. Now, work done from PV graph. Work done from PV graph. Some people use different terms for this graph, but basically, suppose this is one figure, V, P. Here pressure P1, volume V1, or pressure P, volume V. State A to B, gas expand होती है. Here this is the volume V1. It is V2. C, D are the points. So it is PV2. So how to find work done during this expansion? Just now I told you pressure into volume, change volume होता ना, तो that P into V2 minus V1 here is equal to area A, B, D, C equal to work done. Area under this graph, this area work done, one figure. But now if this graph between pressure and volume does not come this way, if the graph is like this, volume, pressure, A to B, here P1, V1, and here P2, V2. Then how to calculate the work done? Let we take here C and D point, V1 और ये V2 वॉल्यूम. प्रेशर यहाँ P1 था, यहाँ P2 घट गया, decreased. Then how to calculate the work done from this graph? Area under the graph is equal to work done. So we take here, suppose this is strip M, N, R, S. So here M and N are so close, this distance we take as delta X. या delta V कह सकते हैं आप इसको, delta V. And this is pressure. Here M and N are so close, that pressure of gas at M and N is the same. Let it be Pi. So this dW Pi into delta V. And that way, if we want to find out the area of whole graph, then we divide in strips and calculate the area this way of all, and it comes to be equal to the area work done from work done in changing the volume from V1 to V2. W is equal to summation Pi I equal to 1 to N and dV. If here, delta V, delta V. The P1, the delta is the same. The width of all strips same, only pressure will change. Or if delta V tends to 0, if delta V is very small, is small, how much small? So that pressure for the given width remains same. Pressure for the given width same. Then we write W equal to integration V1 to V2 P dV. Basically, this is the simplest method of calculating the work done during by thermal system during expansion. If volume of gas increases, work done come out positive. If volume of system increases, then work done is positive. And if volume decreases, work done negative. Positive work means work is done by the system. Positive work here means work is done by system. And negative work means work is done on the system. This is very important to understand. If work done positive, the work is done by the system during expansion. And negative means you have decreased the volume, means we are compressing by using some external effort on the system, and that work is done on the system. Now there are many things here also. Work done during this expansion or compression does not depend only on initial and final position. In thermodynamic system, in thermodynamics, you can say like this. Work done by a system does not depend on the initial and final conditions of thermodynamic system. जैसा भी कहा हमने V1 से V2 वॉल्यूम है चेंज, वॉल्यूम है तो ओनली वैल्यू V1 V2 is not sufficient. Here the work done by system depends on path followed. Path followed. The path followed means process followed. How do we increase or decrease pressure? For example, here in the given graph, the pressure and volume of gas changes in processes processes IAF and IBF. क्या है IAF IBF? Let me draw this diagram here. This is pressure here, volume here. है भाई, प्रेशर वॉल्यूम बोर्ड साफ नहीं हो रहा. Volume. Are we taking on x-axis pressure? So this is the initial position. It goes via IAF here, F here. This process. First we expand gas at constant pressure. Then we suddenly decrease pressure. Path forward, process forward means how to change pressure and volume. That is the meaning. And then we come here via this process. First we decrease the pressure, keeping volume constant, and then we increase the. So I told you area under PV graph is equal to work done. So work done in process IAF. And the path followed, please. The term here is used path followed. Path followed is not moving system here, but pressure volume. How do we change pressure and volume? That is the meaning of path followed here. So in this process IAF, first we keep pressure constant, increase the volume, and then decrease the pressure, keeping volume constant. This is one method. This is one path followed. And in IBF we decrease first pressure, volume kept constant, and then keeping pressure constant, we increase volume. So work done in path IAF is equal to area IBIA here. Let me mark it as A dash B dash. So it is IA A dash B dash I. This whole area under the graph. No work is done during A to F. Why? Because volume does not change. W equal to P delta V. If delta V is change, volume 0, so work done 0. And similarly, work done in process IBF is equal to area AF A dash B dash B. This area only. So apparently area since area under IA is greater than area under BF line. So work done by pressure IAF greater than IBF. Though pressure and volume has changed from here, I write PIBI to PFBF. Here it is important to note that work done in changing the state of thermal system does not depend only on initial and final state. It depends also on the process followed. Path followed. Path followed means process. Here we first keep the pressure constant, increase volume, then decrease the pressure, keeping volume constant. So work done depend not only on final initial position. Now there is one thing, cyclic process. Work done in cyclic process. Cyclic process. These terms are used in thermodynamics in describing different situations. In thermodynamics, what is that? If a process starts from one point and after passing through different state, return back to original position. If a system is starting from one state and after passing through different states, return back to original state, then the process is cyclic. We can represent graphically it like this. Volume pressure. State A, it goes to B and then return back, suppose by this process. This is cyclic process. ACB, DBDA. So here work done in process A to C this area, and this work done positive. Now B to B, the whole area. So work done in compression is more than work done during expansion. So net area of this loop, this area of the loop will be net work done on the system. This area of loop here A, C, B, D, A is the net work done on system. If the process, cyclic process, this is anti-clockwise process. If you take clockwise, suppose PV graph like this, state A से A, B, B, C. So now the work done in expansion is more than this area will be work done by the system. So if cyclic process takes place in clockwise manner. Clockwise. The work is done by the system. And vice versa. Means if anti-clockwise work is done on the system. So these are few terms which I try to explain you. Now in next video I will come to internal energy and first law of thermodynamics. In next video we will take internal energy of thermal system and first law of thermodynamics. Thank you.